Okay, well, let's start. The first point I'd like make is that switch reluctance motor has been developed around the concept of short pitching each phase winding generally around a single starter tooth. By employing such winding configuration, coupling between machine phase is completely eliminated, so the torque is generated due to the rate of change of self-inductance of the excited phases. In constant to conventional SIM, the new winding configuration allows to produce the entire torque from changing mutual inductance between phases. Next, we'll deal with fundamental operating principle of conventional SIM.
In order to explain the basic principle of operation, an example of three-phase of 6 to 4 SIM will be used. The main principle of operation will remain same in the machines having different stator-rotor pole configuration. As you can see from this image, a conventional short pitched SIM with single phase excited. It's clear the other two phases will not contribute the magnetic force which drives flux through stator teeth S1 and S4 and produced anti-clockwise torque on the rotor teeth R1 and R3. The self-inductance of any phase rises as rotor teeth come into alignment with the excited stator teeth, and consequently the torque is produced according to equation 1. Another interesting point is the more general expression for torque in the three-phase reluctance machine is given in equation 2. The next point is conventional SIM. The self-inductance of phase winding consists of a constant leakage value plus a much larger component in equation 3. Where L phase is total inductance of phase. L1 is the leakage inductance per phase. N is number of turns per phase. Alpha is the machine axial length. G is air gap. Beta L is the length of overlap between stator and rotor teeth through which flux generated by the phase current will flow. Let's talk a little bit about the MCSIM model with finite element method. We will look at equation, so now let's turn to model with finite elements. The examined model of the switched reluctance motor is three-phase 6-4 motor, which has 6 stator and 4 rotor poles. The three-phase winding arrangement of the examined mutually coupled switched reluctance motor and its excitation pattern with unpolar current are illustrated in Fig. 3. The finite element method model of SIM and MCSIM have been built to predict the performance by using ANSYS. Material properties defined as BH magnetizing curve are shown in Fig. 4. Since the core material properties of MCSIM is the same as core materials properties of conventional SIM, the model of MCSIM has non-linear characteristic as well. The element defined by 8 nodes for 2D model has been used in the finite element model of MCSIM. The element type has 3 degrees of freedom per node. Magnetic vector potential, current, electromotive force. The finite element method of MCSIM consists of approximately 600 elements and 1600 nodes. We look at Fig 5.
Let's compare model results with calculated results. We have a look similar data. Thanks.